Let's practice dividing fractions and mix numbers together. In each of these practice problems, we're going to go ahead and practice the process of rewriting division problems as multiplication problems and then just multiplying those fractions to get the answer to the division problem. If you'd like to download this free blank PDF, you can find a link in the description box below. And also with the link, you'll find a detailed PDF answer key as well. Let's get started. For number 1, we have 4 divided by 2. Now keep in mind that 4 as a fraction is just 4 over 1, and then 2 as a fraction is 2 over 1. So this is going to be the same thing, but now we have a numerator and denominator for each. Okay, so that's always step 1. After this, we're going to go ahead and rewrite this as a multiplication problem. Now, in order to do that, what we're going to do is keep the first fraction, always leave that one alone, but then you're going to change the division sign to a multiplication sign, and then afterwards you're going to flip this 2 over 1, and we're going to make it 1 over 2 instead. So if we go ahead and do that, it's going to be 4 over 1 times 1 over 2, just like this. Okay. If we do that, then we can go ahead and write one long fraction bar and go ahead and evaluate this. And we're going to go ahead and break down any composite numbers. So this 4 over here, 4 is going to break down into 2 times 2. So 2 times 2, and then the 1 is going to stay over there. And on the bottom, we have 1 times 2. Okay, so at this point, we can go ahead and look to cancel out any common primes on top and bottom. Looks like on top and bottom, we both have a 2, right? So we can go ahead and cross out a 2 on top and bottom. And then I think that's it, right? These 1s technically can go away as well, but if we go ahead and multiply, then we should end up with 2 times 1 on top, which is 2, and then 1 times nothing on bottom is just going to be 1. So the answer here is just going to be 2. Let's go ahead and write that as 2. So again, this process is a little bit long just to say that 4 divided by 2 is 2, but hopefully this will make more sense once we practice it with the fractions. For number 2, we have 7 divided by 7, so 7 is the same thing as 7 over 1. We're going to divide this by 7 over 1 as well. And hopefully you know anything divided by itself is going to equal 1, so that should happen here as well. So let's see what this equal to. So again, let's practice keeping the first fraction the same, so 7 over 1. And then we're going to go ahead and change division to multiplication. Next, we're going to go ahead and find the reciprocal of this. That's what you call when you flip a fraction upside down. So that's going to be times 1 over 7. And now we're just multiplying fractions, which we just practiced in a previous video. So 7's prime, so 7 times 1, 1 times 7. Now we're going to look to see what can we cancel out. Looks like they both have a 7 on top and bottom. So we're just left with 1 over 1. What's 1 over 1? 1 over 1 is just equal to 1, which makes sense because 7 divided by 7 is equal to 1. For number 3, we have 15 divided by 3. So 15 is 15 over 1 divided by 3, which is going to be 3 over 1. Okay, we're going to go ahead and rewrite this as a multiplication problem. So 15, the first one's going to stay the same, 15 over 1. Then we're going to multiply, and we're going to reciprocate or flip this 3 over 1 to make it 1 over 3, just like that. Okay, now when we're multiplying fractions, remember we can just multiply the tops and the bottoms. Do you see any composite numbers? Well, yeah, 15's composite, so 15 breaks into 3 times 5 times 1, and on the bottom we have 1 times 3. Now look for those matching primes, so 3 and 3 are in common here, and then I think that's it. And so if we multiply 5 times 1 on top, that's going to be 5, and then on bottom we just have a 1, so what is 5 over 1? Well, 5 over 1 is just 5, which is our answer. Okay, let's try one more where we're not even dealing with fractions yet. We have 20 divided by 4, and so hopefully you know 20 divided by 4 is 5, right? So let's see, we should get 5 as our answer, but let's just practice this algorithm. So 20 is 20 over 1, 4 is going to be 4 over 1, okay? And we're going to go ahead and rewrite this as a multiplication problem, so that's going to be 20 over 1, keep that. We're going to multiply, we're going to flip this 4 over 1, we're going to make that 1 over 4. Okay, so at this point, we're going to go say that we have this composite number of 20 and a composite number of 4. So what does 20 break into? 20 breaks into 2 times 10, and the 10 breaks into 2 times 5. So we have 2, 2, 5, and 1. And on bottom, we have the 1, and then 4 breaks into 2 times 2. Alrighty, so these 2's will cancel out, and these 2's will cancel out. So on top, we're just left with 5 times 1, which is going to be 5. And on bottom, 1 times nothing is going to be itself. It's just a 1, right? So it's not times 0, it's just a 1. And then we're going to have our final answer of 5. Okay, so there you have a few where you're just getting used to the strategy here with just normal numbers, so you can check to make sure your answer does make sense. Here's number 5, our first one where we're actually dealing with fractions. Okay, so same process here. 4 is the one that's not a fraction. Let's write that as 4 over 1. Now the 1 over 2 is already a fraction, so keep that as 1 over 2. We're going to keep the 4 over 1. We're going to write multiplication sign, and then we're going to flip this or reciprocate 1 over 2 and make it 2 over 1. Okay, so if we go ahead and write this as one fraction here, this is going to be 4 is the same thing as 2 times 2, and we have a 2. So again, this was a composite number. On bottom, we just have 1 times 1. So 2 times 2 times 2 is going to be 8 over 1, and 8 over 1 is just equal to 8. Okay, so if we fit a half into 4, a half can fit into 4 8 whole times. For number 6, we have 3 divided by half, so 3 is 3 over 1 divided by 1 over 2. So how many halves fit into 3 is what the question is asking. And so keep the first one, 3 over 1, and then multiply by the reciprocal. That's this flipped 1 over 2 will be 2 over 1. Okay, and so written as one fraction here, they're both prime, so 3 times 2 is going to stay, 1 times 1 is going to stay, 3 times 2 is 6, 1 times 1 is 1. So the answer here is just going to equal 6. So if you had 3 whole cookies and you cut them all in half, there are 6 of these pieces that are half size each. Okay, for number 7, we have 2. 2 is going to be 2 over 1, and we're dividing this by 1 over 2. So we have 2 cookies, and we're cutting them into halves, figure out how many of those pieces we have. And so the first one stays the same, 2 over 1. We're going to multiply by the reciprocal of 1 over 2, which is going to be 2 over 1. Then these are both prime numbers, so we can keep them the same, 2 times 2, 1 times 1, 2 times 2 is 4, 1 times 1 is 1, so we have 4 over 1, which is just 4. So if you have 4 halves, that's the same thing as 2 wholes. For number 8, we have 5 divided by half, so 5 is the same thing as 5 over 1. We're going to divide this by a half. So rewriting this as a multiplication problem, 5 over 1 is going to stay the same, but 1 over 2 is going to reciprocate or flip it upside down. So we're changing 2 things here, division to multiplication, and then 1 over 2 to 2 over 1. As one fraction, 5 and 2 are both prime, so they're going to stay, and 1 times 1. 5 times 2 is 10, 1 times 1 is 1. So 10 wholes is going to be 10 wholes, or 10 of these pieces. Okay, so if you had 5 cookies, you cut them all in half, there are 10 pieces. Here's number 9. For number 9, we have this 2 divided by a third, so 2 as a fraction is going to be 2 over 1 divided by 1 over 3. And let's see, let's go ahead and rewrite this as a multiplication problem. So we're going to keep the 2 over 1. We're going to change the division to multiplication. Then we're going to reciprocate or flip the 1 over 3. We're going to make that 3 over 1. As one fraction, this is going to be 2 times 3 over 1 times 1. 2 times 3 is going to be 6. 1 times 1 is 1. So this is 6 wholes. So the answer here is going to be 6. For number 10, we have 3 wholes. So 3 is going to be 3 over 1 divided by 1 over 3. Okay, so let's keep the 3 over 1 as 3 over 1. And then let's go ahead and multiply. And let's flip this 1 over 3 upside down to make it 3 over 1. Okay, so on the top, 3's are prime, so we're going to have 3 times 3. On the bottom, 1 times 1. 3 times 3 is going to be 9. 1 times 1 is 1. And so what we're going to have here is 9 wholes, which is 9. So imagine you had 3 cookies and you cut them all into third size pieces. Then there would be 9 of these 1/3 size pieces. For number 11, we have 4 divided by a third. So imagine 4 cookies and cutting them all into third size pieces. How many total pieces would we have? Maybe you can imagine that, what that would be. So let's go ahead and divide 4 over 1 divided by 1 over 3. Let's rewrite it as a multiplication problem. So let's do 4 over 1 times, and let's go ahead and flip this 1 over 3. Again, always flip the second one, and that will be 3 over 1. So let's see. 4 is composite, so we can go ahead and rewrite that using its prime factorization of 2 times 2. So we have 2, 2, and 3. I guess it doesn't really matter in this case just because there's nothing on bottom to cancel out with it. But 2 times 2 is 4, 4 times 3 is 12, so we have 12 over 1, and that's just equal to 12. For number 12, let's see what we have here. We have 7 divided by a third, so 7 is 7 over 1. We're going to divide this by 1 over 3. And let's go ahead and rewrite this as a multiplication problem, so keep the 7 over 1. And let's go ahead and multiply this by the flipped version of 1 over 3, which is just 3 over 1. 7 and 3 are both prime, so we don't have to break anything down. 7 times 3, 1 times 1. 7 times 3 is 21, and 1 times 1 is 1. So 21 over 1 is just 21. For number 13, we have this 4 divided by half. So 4 as a fraction is going to be 4 over 1 divided by half. That's going to stay the same for now. And let's go ahead and rewrite this as a multiplication problem. So 4 over 1 stays the same. Let's write multiplication, and let's flip this 1 over 2. Let's make it 2 over 1. Okay. Now 4 is going to be composite, so we can technically break it down. But keep in mind that on the bottom, we just have 1, so nothing's going to cancel out anyway, so you can just leave it if you want. But for consistency, I'm just going to write 2, 2, and 2, break that 4 down, then 1 times 1 on bottom. 2 times 2 times 2 is 8, which makes sense because, 4 times 2 is 8. On bottom, we have a 1, and so 8 over 1 is just going to be 8. So imagine you had 4 cookies and you cut them all into half-size pieces. There's going to be 8 of these pieces. For 14, we have 3/4 divided by 1/4, so let's go ahead and just rewrite this 3/4 divided by 1/4. Now, if we're going to go ahead and rewrite this as a multiplication problem, then we're going to keep the 3 over 4, then multiply by the 4 over 1. So make sure we flip that second fraction upside down. Then as one fraction bar, we can go ahead and break down these 4s into their prime factorization. So we have this 4 and this 4. So the 3 is going to stay the same, right? And then the 4 is going to break into 2 times 2. And this 4 is going to be a 2 times 2, and we have a 1. Okay. Now these 2's can cross cancel. Maybe pick these 2 and then these 2. And then on top we're just left with a 3, and the bottom we're left with a 1. So 3 over 1. And so this answer is just going to be 3. So imagine you had 3/4 of a cookie and you split them into quarter-sized pieces. There'd be 3 of them. For number 15, we have 7/8 divided by 1/8. So imagine you have 7/8 of a cookie and you cut them into 1/8 size pieces. So let's go ahead and see how many pieces would there be in total. So keep the 7 over 8 and then multiply by 8 over 1. So flip that 1 over 8 and reciprocate it. Now as one fraction bar, we can go ahead and break these 8's up. But actually, if you notice, you can actually just cross out the 8 with the 8, but I'm just going to show the prime factorizations just so you can see it. But in the future, feel free to use that as a shortcut and just cross out the 8's. So we have all these 2's. Hopefully you've done enough prime factorizations where 8 comes from 2 times 2 times 2. These 2's cancel out, these 2's cancel out, and these 2's cancel out, which makes sense because 8 over 8 would cancel out. So we're just left with 7 over 1. And 7 over 1 is just 7. So you'd have 7 of these 1/8 size pieces. That fits into 7/8. Okay. For number 16, we have 2/3 divided by 1/3. So imagine you have 2/3 of a cookie and you split them into 1/3 size pieces. So I think we should have 2 as our answer, right? But let's check 2 over 3 times 3 over 1. So notice we just flipped this 1 over 3 upside down. As one fraction, we can write this as 2 times 3 over 3 times 1. Everything's prime here, so we can't break anything down, but these 3's are common, so we can cross those out. And then on top, we're going to have 2, and on bottom, we have 1, so 2 over 1 is just 2. Cool, so that's the first 16 problems. Let's check out number 17. So for 17, we have 3/5 divided by 1/5, and so right away, let's go ahead and write 3/5 divided by 1/5, and as a multiplication problem, this is going to be 3/5 multiplied by 5 over 1. Okay, and so as one whole fraction, we're going to go ahead and write this as 3 times 5 on top, and then 5 times 1 on bottom. These 5's can cancel out with each other, and we're going to be left with 3 over 1. And 3 over 1 is just 3. So that would be our answer here. Okay, next one, we have 7 over 10, and let's go ahead and divide that by 1 over 10. All right, as a multiplication problem, that's going to be 7 over 10, keep the same, multiplied by 10 over 1. So flip that second one upside down and go ahead and see what can we cancel out with each other. So it looks like the 10's will cancel out, but I'm just going to go ahead and show that as one fraction bar. We're going to have 7 is prime, 10 is 2 and 5, and 10 is 2 and 5 on bottom. All right, so feel free to cancel those out before doing this if you want to save some time. I'm just showing you why we can do it. So we have 7 over 1, and that's equal to 7. Okay. For number 19, we have 3/4 divided by 3/4. Remember, anything divided by itself is going to be 1, so we should know the answer before we start this, but we're practicing just showing the process here. So this is the division problem. As a multiplication problem, it's going to be 3 over 4 times 4 over 3. All right, and so notice what's going to happen here, but everything on top and bottom matches, but we can go ahead and take this 4 and this 4 and break those down. 3 and 2 and 2. 2 and 2 and 3. So as we suspected, we're going to get everything to cancel out here. And so we're left with 1 over 1, which makes sense because 3/4 cut into size of a 3/4 would just be one piece. So the answer to this is going to be 1. Okay. For number 20, we have 2/5 divided by 2/5. Same idea here. We should get the answer 1, but let's just make sure this works. So 2/5 divided by 2/5. Okay, once you get the hang of this, it should go a little quicker. We have 2/5 times, and we're going to put 5 over 2. Okay, so as one fraction here, we can go ahead and write 2 times 5 on top, and then 5 times 2 on bottom. Notice how everything's going to cancel. The 2's and the 5's match. So just like in number 19, we're going to get 1 over 1, and so that's just equal to 1. Okay, so let me just go ahead and show that we had ended up flipping this one over here. We ended up flipping this. We flipped this one as well. It's always the second one, so hopefully you're getting the hang of that and not flipping the first one, but always the second one. For 21, all right, these ones are a little bit different just because things don't go in as nicely, but that's okay. So we're going to practice doing slightly different ones here. So we have 3/5, and let's divide this by 1/2. Okay, so that's the original problem, but again, this is the same thing as 3 over 5 multiplied by 2 over 1, okay, as a multiplication problem. Then everything's prime here, so nothing can be broken down. So 3 times 2, 5 times 1. 3 times 2 is going to be 6, and 5 times 1 is 5. So as an improper fraction, that's going to be our answer. As a mixed number, you can say that's going to be 1 and 1/5, right? 5 fits into 6 one time with 1 left over. For 22, we have 4/7 divided by 1/3. So here's 4/7 divided by 1/3. That's the original. As a multiplication problem, this is going to be 4 over 7 multiplied by 3 over 1. Now this 4 is composite, so it can break down, but 7 and 3 don't seem to have anything in common with it just because they're also prime. So 4 is 2 and 2, and we have 3, and 7 is just 7 and 1. So nothing can cancel out, but it's helpful to kind of just see the prime factorizations to check. 2 times 2 is 4, times 3 is 12, so we have 12 over 7 times 1, which is 7. So our answer is 12/7 as an improper fraction, but as a mixed number, 7 goes into 12 one time with 5 left over, so 1 and 5/7. Okay, moving on to 23 here. The original is going to be 5 over 6 divided by 3 over 7. Okay, as a multiplication problem, this is going to be 5 over 6 multiplied by 7 over 3. Okay, so let's see what can be broken down here. So it looks like this 6 is the only composite number. So 5 is prime and 7 is prime. Can't be broken down. 6 is the same thing as 2 times 3, and then this 3 is going to stay. I don't think anything is in common top and bottom, so 7 times 5 is going to be 35. And then 2 times 3 is 6, and 6 times 3 is 18. So that's our answer. As an improper fraction, as a mixed number, 18 fits into 35 almost twice, right? 2 times 18 is 36, so I'm going to put 1 and 17/18. Okay, so almost twice, off by 1 here, so we get 1 and 17/18. For number 24, we have 1/6 divided by 2/5. Okay, so let's go ahead and see, as a multiplication problem, it's going to be 1 over 6 multiplied by 5 over 2. Okay, and we have one composite number, it's this 6. But 6 doesn't seem to have any factors with 5, so I don't think we're going to be able to cancel anything. So 1 times 5 stays the same. 6 is going to be 2 and 3 and 2. So again, yeah, nothing in common, so it didn't really matter if we broke it down or not. We get 5 on top. 2 times 3 is 6, times 2 is 12, so 5/12 is our final answer. It's a proper fraction, so I'm just going to write it over here to be consistent, right? But just notice that we flipped this, we flipped this, we flipped this, and we flip this. Hopefully you're getting the hang of it even when I don't write those arrows. And just also keep in mind what we were breaking down here. So the 2's came from that 4, the 6 broke into 2 and 3, and the 6 broke into 2 and 3. So it's easier to break numbers down when they're smaller as opposed to doing it later. Here's 25. Okay, for 25, we have 3/8 divided by 3/5. So let's go ahead and write, that's the original, 3/8 divided by 3/5. Okay, as a multiplication problem, this is going to be 3 over 8 multiplied by 5 over 3. Okay, now as one fraction bar, let's see, can anything be broken down? Well, I think this 8 can be, right? 8 is composite. So 3 and 5 are both prime, so we're going to leave the 3 and the 5. 8 breaks into 2, 2, and 2, and we have a 3 down here. Okay. Now this 3 and 3 can cancel out with each other, but I think that's it. And so on top we just have 5, so that's going to be the numerator, and on bottom 2 times 2 is 4, 4 times 2 is 8, so 5/8. So final answer here is going to be 5/8. For number 26 we have 4/5, and let's see how many times 2/5 will fit into it. So 4/5 divided by 2/5. Let's go ahead and rewrite this as a multiplication problem. 4 over 5 times 5 over 2. We got some composite number, no, just one, just this 4 here, okay? And so this, as one fraction bar, this 4 will break into what? 2 times 2 times 5, all over 5 times 2. Cool. So let's see what cancels out here. The 5s, cool, and the 2s. Alrighty, so on top we're just left with 2, and on bottom we're just left with nothing, so we're going to put a 1 there always. And so 2 over 1 is just 2. Hopefully it makes sense that 2/5 fits into 4/5 2 times. For number 27, we have 9 over 14 divided by 6 over 7. Alright, so as a multiplication problem, this would be 9 over 14 multiplied by 7 over 6. Alright, so let's see what can be broken down. So 14 is composite, 6 is composite, they're both even numbers, and 9 is composite. So 9 breaks into 3 times 3, and the 7 is already prime. 14 on the bottom breaks into 2 times 7, and 6 breaks into 2 times 3. So on top here, looks like we can cancel out a 7 with a 7, and a 3 with a 3, and I think that's it. So on top we just have 3, and on bottom we have 2 times 2, which is going to be 4. So I think the answer here is going to be 3/4. Okay. For number 28, looks like we have a mixed number. So be careful with this here. Let's go ahead and just take this mixed number right from the beginning, and let's go ahead and rewrite it as an improper fraction, right? So 4 times 3 is going to be 12. 12 plus 1 is going to be 13. So this is going to be 13 over 3 divided by 1 over 2. So always take those mixed numbers and convert them right away. And then as a multiplication problem, this is going to be 13 over 3 multiplied by 2 over 1. As one fraction bar, I think everything here is prime, so we have 13 times 2, 3 times 1, and there's nothing in common. So on top 13 times 2 is going to be 26, and on bottom 3 times 1 is going to be 3. Now that's our answer as an improper fraction, but how many times does 3 fit into 26? I think 3 times 8 is 24. That's as close as we can get with 2 left over, so 8 2/3 would be our answer as a mixed number. Okay, so far, let's just go ahead and recap that for each of these, we flipped this second fraction, we flipped this one as well, we flipped this one as well, and let's see what numbers were broken down. So 8 and 25 was broken into 2, 2, 2. This 4 and 26 was broken into 2 times 2. In 27, 9 was broken into 3 times 3, 14 into 2 times 7, 6 into 2 times 3. And in 28, nothing could be broken down because everything was prime. All right, last few here. Let's check out 29. So for 29, it looks like we have a proper fraction of 3/5, but then we have a mixed number. So let's go ahead and take care of this mixed number right away. 3 times 3 is going to be 9. 9 plus 2 is 11. Okay, so we're going to have 3/5 divided by 11 over 3. And so that's the original problem, but written using improper impropers. Now, as a multiplication problem, this is going to be 3 over 5 multiplied by 3 over 11. Now, I don't think anything can cancel out or be broken down because everything is prime. 3, 5, and 11 are all prime. 3 times 3 is going to be 9, and 5 times 11 is going to be 55. So the answer here is just going to be 9 over 55. For number 30, we have a mixed number here of 3 2/5, and then we have another mixed number of 4 1/2. So let's go ahead and rewrite those as improper fractions first. Okay, so for 3 2/5, 3 times 5 is 15. 15 plus 2 is going to be 17. So this is the same thing as 17 over 5 divided by, and then for 4 1/2, 4 times 2 is 8. 8 plus 1 is 9. So this is going to be 9 over 2. Okay, so let's go ahead and rewrite this as a multiplication problem. So 17 over 5 multiplied by 2 over 9. Okay, so it looks like the only one that could be broken down is this 9 here. 9 breaks into what? 3 times 3. which doesn't match anything on top. So we actually know nothing will cancel out, but 17 is prime, 2 is prime, 5 is prime, and then 9 breaks into 3 times 3. Okay, so nothing too exciting. On top here, 17 times 2 is going to be 34. And on bottom, 5 times 3 is 15. 15 times 3 is going to be 45. So our answer here is going to be 34 over 45. So let's go ahead and write 34 over 45. For 31, we have 4 and 2/3, and we're going to go ahead and divide that by 2 and 5/6. So we have two mixed numbers again. So let's go ahead and take this 4 and 2/3 and make it an improper. 4 times 3 is 12, plus 2 is going to be 14. So that's going to be 14 over 3 divided by, and then for 2 and 5/6, 2 times 6 is 12. 12 plus 5 is going to be 17. So that'll be 17 over 6. What is this as a multiplication problem? So 14 over 3 stays the same. We're going to multiply this by 6 over 17. Okay, let's see, what can be broken down here? The composite numbers here are 14 and 6. 3 and 17 are prime, so they can't be broken down. 14 is going to be 2 times 7, and 6 is going to be 2 times 3. And the 3 and the 17 are just going to stay the same down there. We can cancel out a 3 and a 3 top and bottom, but I think that's it. And so we can't simplify anymore. And on top, 2 times 7 is 14. 14 times 2 is 28. So we're going to have 28 over 17. So that's our answer as an improper fraction, but as a mixed number, 17 fits into 28 one time with 11 left over. So 1 and 11/17 should be our final answer as a mixed number. And finally, for number 32, we have 6 and 2/3, and we're going to divide this by 3 and 7/11. So let's go ahead and turn these into improper fractions. So 6 times 3 is 18. 18 plus 2 is going to be 20. So we'll have 20 over 3. And let's divide this by the 3 and 7/11. So 3 times 11 is 33. 33 plus 7 is going to be 40. So that's going to be 40 over 11. All right, so that's the same problem as using impropers instead. And then we're going to go ahead and make this a multiplication problem. So 20 over 3 times 11 over 40. Okay, so I think we can break some stuff down here. So let's see, 20 is definitely composite and 40 is composite. Hopefully you notice what maybe you can cancel those out by, but 20 is going to break down into 2 times 10, and 10 breaks into 2 times 5, and we have this 11. 3 is going to stay the same. 40 breaks into 2 times 20, and 20 we already know breaks into 2, 2, 5. Okay, so this right here is going to be the whole thing written with the prime factorizations, and let's see what we can cancel out here. So hopefully you know 20 and 40 are, 20 is a factor of 40, 40 is a multiple of 20, so these 2's, and these 5's should make sense to cancel out with each other. Okay, so what are we left with here? We are left with, looks like 11 on top, so that's going to be 11 over, and then 3 times 2 is going to be 6. So again, if you break those down, then you won't have to do any simplifying later. And then this is the same thing as 1 and 5/6. And then we're done. So there you have 32 different practice problems with practicing dividing fractions. And so keep in mind that you can rewrite all division problems as multiplication problems, just like you can rewrite all multiplication problems like division problems. So if you found this video helpful, please let me know in the comment section down below, and please consider giving the video a thumbs up as well. And as always, keep up the great work, and I'll see you in the next one.